Hey guys, welcome to Code Decode. Today in this video, we'll be looking into frequently asked Docker interview questions. Even if you don't know Docker, don't worry, we will start from scratch in the basic interview questions and we will take it to an advanced level. Also, we have created multiple demos for you. Dockerizing a single application, Dockerizing multiple applications with Docker Compose, and many such demos are created. If you want to have this recreated with the live demonstration of such projects, just let us know in the comment section. The next video will be taking on the live demonstration of Docker in Spring Boot project, live demonstration of project and Microservices project, and how to make them interact with each other. But we will be using the snapshots from these running projects only for summarizing the interview questions. So let's get started. Please like, share and subscribe to support us so that these videos reaches to more of the people who are preparing for interviews like you. What is Docker? So if you can see here, this is the logo of Docker. You can see there is a whale carrying multiple containers here. So you can consider it something very similar to an analogy of cargo ship. So Docker has the ability to hold multiple containers having distinct objective and IDs. A Docker is a way to create your application in containers. These containers have different objectives and IDs who are capable enough to run your application. So each container will contain your one segregated application which is capable enough to solve one particular task. For example, if you have multiple microservices, you can create multiple containers for each microservice. I'll give you an example of that also. This is a Docker desktop. You can have containers for vaccination center, citizen service, database. Now database, you can have a separate container and you can have your applications interact with the database. So you can have two different containers interacting with each other using networking and storages. So this is how you can create multiple containers and deploy your application segregatedly. Now what does these containers contain? So these containers contains items. Items as in application, jar and their respective dependencies. So that is a total ecosystem required for your application to run perfectly fine. So suppose your application needs MySQL, it will be, the jar for MySQL will be there. If your application needs Spring Framework jars, they will be there. I'll give you an example. Suppose this is my vaccination center microservice. If you go into the packages, you can see Spring Framework jars with the perfect version that is needed to run your application exactly how it has to run. Proper package with all its proper versions and dependencies resolved will be packaged together into one single component and will be added to your container, so that this container, when dispatched to multiple places, will run same as how it works on your local. And hence Docker says that if you find an issue that your application runs on your machine, does not work on your teammate's machine, that issue is solved by Docker, because you containerize or you encapsulate your application and all its dependencies, be it Spring Security, Spring Dependency, everything in one single package. Here you can see as vaccination 1.0.0.0 in one package, so that your application runs with the exact same dependencies everywhere. You can also see, if I find the .jar, you can see that even your snapshot for your vaccination center is also here. So this is your application. The previously packages I have shown were the Spring Boot packages. All these packages, that is 313 packages together, will make your application run perfectly fine in any environment. Images are created using templates called as Dockerfile. So I'll come back to this analogy again. When you understand what is Dockerfile, when you understand what is Docker image, when you understand what is container, then this analogy will make some sense to you. So let's first understand what is Docker. So Docker is a containerization platform. That means it helps you to create containers. If you can see, there are multiple containers. So the task of Docker is to help you create these containers. And what these containers do, they help you package your application and all its dependencies together in the form of containers. So all these dependencies that you can see here will be packaged together to create your runtime container, so that it ensures that your application works seamlessly in any environment, be it your local, be it your dev, be it test, be it production. Everywhere your application works seamlessly fine and same. Hence a container contains a complete ecosystem of your application. Also, if you can see here, this is a MySQL connector jar. Your application needs to connect to MySQL. That MySQL is another container. If you can see here, there is a MySQL container here. So these MySQL, to connect with this particular MySQL container, you need a MySQL connector. So even that connector dependency you can also find here in your packages. Hence everything you can find here in your container, and hence it is a complete ecosystem for your application. This guarantees that software will always run same regardless of its environment, and that was about Docker. Now how does Dockerfile image and containers are created? So if you go into the source code, here is where you start Dockerizing your application. First step is to create a Dockerfile. And Dockerfile is nothing but an instruction that will be given on how to create your image and your container. This you can see is an example of a Dockerfile. I have given all the instruction on what all each and every line do so that you understand what Dockerfile is. When you build the Dockerfile, creates your images. If you can see, these are your images. And when you run these images, that is you run or Docker run, then your containers are created. So containers are runtime instances of images that you have created using the Dockerfile. So remember this flow, this is very important. First thing that you need to do is create a Dockerfile. When the Dockerfile is given a docker build command, an image is created which is read-only image. You cannot change it anyhow. Just a snapshot or a blueprint, just like a class in Java. After that, when you run this image, that's where your container is created, which is a runnable instance of image only, which is objects in Java. So this is something similar analogy. Your class is a blueprint of creating an object. Your image is a blueprint of creating a container. Your container will contain all those things and only those things that will be given as a definition in image. So here if you can see, I have multiple images. Only those packages, 313 packages which are part of this will become a part of your container also. Now, if I have not added any of the connector to Oracle, then you cannot connect any of the applications in that container to Oracle. So only things that are there in image will become a part of your container. A Docker file is a text file which provides a set of instruction to build a Docker image. So these are set of instruction to create a Docker image. Now let's understand a Docker file with line by line so that it will help you understand how your image is created. So from OpenJDK 17 Alpine. So what is this from instruction that we give to the Docker for creating an image? It specifies the base image of your application. So our application uses OpenJDK to run. Now this is the base image OpenJDK, and Alpine here is a flavor that it says it will be developed upon the Linux kernel. So remember, if you have used a base image which is Linux compatible, it will not work in any of the server which is having Windows on it. So remember to use only that image which is compatible to all your servers across all your networks. So this is a very important instruction that you give as a first line itself, which base image is to be used, and then all the commands that you use now will help you create incremental image. So second says working directory /opt. This command is used to define a working directory of the Docker container. Now when you create an image, from that image, when you run that image is where the container is created. Now in that container, where all the commands has to run. Like if I say any command, say run the jar, where that command will run, that working directory in the Linux container where it will run, that is the current working directory. So with working directory command, you define which working directory of the container will be used to run any of the command like run, cmd, entry point. All such commands will be executed in that specific working directory only. So everything you can find in the container you will find in /opt directory. Here also, if you go into the image of citizen service, you can see search for your jar. Your jar will be named as app.jar in the opt directory. Where how will you define that? In the opt directory, copy this jar and create this jar. This is through line number 2. Third is env port and the port number. So env is an instruction which is used to define the environment variables. So you have created an environment variable known as port and 8089. So this port is useful. All your networking will be done through this particular port number. Then that's expose instruction that informs Docker that a container is listening to the specified network port at runtime. So since you are exposing 8089, your container is going to listen to the network at this 8089 only. Next, copy. Now this is where I want to say that /opt app.jar. So whenever you do the Maven install, after Maven install is successful, you can see in the target folder I'm capable enough to create a jar. So the jar is named as demo001 snapshot.jar. So what it says that copy anything.jar in the target folder to opt folder and name it as app.jar. So it's going to copy this jar in the target folder to which location? The location opt app.jar, and rename that jar to app.jar. So that is done by line number 5. And the last is entry point execute. So entry point is an instruction that whenever your container is initiated or created, the next thing that you need to do is execute this command. Entry point, as soon as you have created your container, what you need to do? Execute. Execute what? Execute a line or a script which says java minus jar your app.jar. So java minus jar, you know this java space minus jar is a command which is used to run your jar. And you have created your jar here, and whenever your container is created, the first thing it will do is it will run your app.jar which you have copied from the target folder to that container, and that this particular jar will be a part of your image. So whenever you build this Docker file, what happens next? You have created a Docker file. Now when your Docker file is built, an image is created, which I can show you here. These are the images that are created. In the image, you can search for your jar. You will see your jar in your opt app.jar name. And when you run this image, a container is started. And as soon as container is started, this app.jar is copied to your container, and when you run java space minus jar your app.jar, your jar starts running. That means your application spins up, it comes into life. That's where all your instructions that you have given is successful. So this is how you create a Docker file. Each line is an instruction on how to create an image, and when you run that image or a blueprint, your container is created, and all the things that you have done gets reflected in your container also. So now let's see what is Docker file. It is a text file. You can see this is a text file. What does it contain? It contains instruction to build your Docker image, which includes the operating system. Where did you define what operating system you need? You have defined it with your base image. If your base image is compatible with Linux, only your operating system Linux will be able to support your application and that image and that container, and Windows will not be able to. So remember to choose this wisely. So the Docker image including the operating system, the languages, environment variables. Here the environment variable we have chosen is port. The file locations, we are going to have the working directory as /opt where all your commands will be running, and other components needed for the image to run properly. So each time a command is run in Docker file. When a command is run in Docker file, when you build the Docker file, and when you try to create an image out of that Docker file, then each command, that is line number 1, 2, 3, 4, 5, 6, each line when you run, a new layer is created on top of previous layer. So when line number 1 says, then a base image is created. Then when you say go to the /opt, then a layer over that base image is created. Then when you create environment variable, then all these tasks will be in place, and above it a port environment variable is defined. So that's how incrementally your image gets created, and this is how a Docker file looks like. If you find it difficult to understand, just let me know in the comment section. I'll make you go through each and everything again from scratch, because I understand this is difficult to understand. Now when Docker file is clear to us, we can move to Docker image, because when you build the Docker file, that's when your Docker image is created. So when we give this Docker file as an input and run the Docker command docker build, then what is created is a Docker image. If you want to see this whole thing, how it works with a live demo, let me know in the comment section. I have my project created. I'll create it with scratch for you. I'll show this how we can do it with a live demo. Now what are Docker images? Docker images are read-only templates like snapshots used to build the containers. So the input to create a Docker image is the Docker file, and when you build that becomes a Docker image, and when you run the Docker image, that is the reason for creating the or spinning up the containers. So image also contains the metadata that describes container's capability and need. So whatever you define an image becomes a part of container by default. What all you need in your application, you have to define it in your image also. Otherwise your container will not be able to access that. So how will you create a Docker image? The Docker build command, when you pass a Docker file, that is when a Docker image is created. And who is the one who is responsible for doing it is a Docker daemon. We will see what is Docker daemon, what is Docker host, all these things when we will go to the architecture or internal working of Docker in the next question. So please till then bear with me, understand that there is a Docker daemon who is the reason behind everything. Whatever command you give, who understands that command is the Docker daemon, and who executes the particular command is also Docker daemon. So Docker image cannot be executed by themselves because it is just a read-only static template. They do not run by themselves. To run or start it, we need to give a Docker command as Docker run, and that's when this blueprint for creating the container is used to create a Docker container. So Docker image is nothing but a blueprint. You can consider Docker images just as a Java class, which is a blueprint for creating the instances in Java. So Docker image is also a blueprint for creating Docker containers in real time. A Docker image is run using Docker run command. The Docker daemon is again responsible for creating the container for that image. So again, who is responsible for creating the container? That is Docker daemon again. Now what you can do with these Docker images? To have the access to Docker image across multiple servers, you can push this Docker image to a public repository or registry like Docker Hub. Now Docker Hub is again a centralized repository. Now consider Docker Hub as GitHub. When you are writing a code and your teammates require the same code to run on his local machine, what do? You push your code to GitHub and give the clone URL to your friend or the teammate, and what he does is it clones and gets your whole project into his local machine or server. The same thing you can do here also. What you do, you create your application in your local, you create your Docker file, you create your Docker image locally, you create your containers by spinning up your image using Docker run command. When your container is ready, as you can see, okay, things are working fine for me. So since it is working fine for me, you can push this image to a central repository just like GitHub known as Docker Hub, and you can push your image to that repository. Now going to dev, going to prod server, going to multiple servers, what you can do is you can pull this image. As soon as you pull this image is in your server, you can run this image using Docker run command. And Docker run command will actually spin up a container for you similar to the containers we have here, and your application will run just like it is working in your local, and which actually removes all the risk of you having your application running perfectly fine in local but not working in production due to some reason. Maybe the dependency conflict or version conflicts, multiple reasons. That will not occur when you use Docker in your application. So Docker push and Docker pull are the commands you can use to push your Docker image and pull your Docker image from the Docker Hub repository, similar to like you use with your code in the GitHub repository. So this is how your image looks like. These are the images we can have, and these are the packages you can have. Now we know what is Docker file, a text file that I have shown you here. Then an image that is created when Docker file is given as an input to the Docker build command, and a static image is created which is just a template and a blueprint. It doesn't run on itself. Now going to another server, you can pull it, create your container. So what is container now? Container must be a runtime instance of blueprint called as image. So container is a runnable instance of image. Image you cannot run or start an image. But what you can start is a container which is an instance of image. So you can create, start, stop, move, delete a container using multiple ways. The Docker APIs or CLI, Docker CLI. Now what is a container? So container is a lightweight platform independent way of running your application. Why is it platform independent? Because it doesn't depend which version of jar is getting downloaded in your local machine. Everything and anything that your application needs will be there in the container itself. Hence, it makes it completely platform independent. It doesn't depend upon what platform you are using, just the operating system matters. So every container is isolated. I say I have two containers, vaccination center and my database. So these two containers are separate containers and they do not share anything. But your application needs to connect with database, that is for sure. So for that they have given you the networking provision. So you can access your database, but you cannot share your resources with your database. So every container is isolated. Your application is isolated from your database, but you can access your database or the resources with the help of Docker networking. So Docker networking is something which is responsible for your multiple containers to interact with each other, also simultaneously being isolated with each other. They do not share anything, but they can access each other using the networking. Also, one of the important point for container is it is volatile. Remember, if you create a container or you spin up a container, if in any case you kill a container or the container crashes, then all its data that you store in that container will be lost. And hence, to prevent such kind of losses, you should use to persist your data using the Docker storage concept. That also you can see here in volumes. So these volumes are something you can use to store your data in Docker, so that even if you lose something, you can have a backup of these volumes, storage volumes. Container is volatile, remember that. Container have access to only those resources that are defined in image. So suppose in an image of citizen service, if I have no package for Oracle, that means your image doesn't support any package for Oracle connection. So you cannot connect your application to Oracle database at any cost, because there is no access to such connectors in your application, in your container. So containers can only access resources that are defined in image. So if you have, that is why if you have only SQL connector, you can connect to only MySQL. You do not have Oracle, you cannot connect to Oracle at all. So only those things that are there in the image can be accessed. Also, all Docker images become Docker container when they run on Docker engine. Now we will see also what is Docker engine in detail. But remember, all Docker images runs on engine to become a container. So that is the flow that we have seen. There is a Docker file. When you build it, an image is created. And when you run this image, a container is created. Now, where do you store these images? The Docker Hub is the one where we can store our images. So let me show you a Docker Hub. I have already logged in with Decode in the Docker Hub. Hence, I can see all my images here. So you can see my container image demo, my container image Eureka, vaccine, citizen, everything, all these images you can see in the Docker Hub. So what I have done is I have pushed these images to Docker Hub, and I can pull this anywhere because this is cloud based. Why is it cloud based? Because I can access it through browsers. So what is Docker Hub? The Docker images, if you can see, this is a Docker image. It contains a Docker image. So Docker images are stored in registry, which is a centralized location for storing and distributing your Docker images. Now if my teammates ask that, okay, now I want to spin up a container on my local and see how the things are working. What he can do is, or she can do is, you can pull this particular image from the Docker Hub, run on your own machine and see how container is spinned up using this particular image. So this is the way to distribute it also among your team members. Similarly, like what you do with your code in GitHub. When you run a Docker container, Docker pulls the image from registry and runs it on your local machine. So Docker pull is the one which is responsible for pulling it and running in your local machine. Several such kind, like Docker Hub is one of such kind of registry. There are several public registries available. Docker Hub is something which I always prefer. It is a default registry for Docker. You can also set up your private registry and store and manage your images internally. Why? Because this is not safe enough. Even though you can make it private, there can be a chances they have the URL, they can access it. To make it manageable internally, you can have your private registry. This is not a private registry. Docker Hub is a cloud-based registry that allows you to pull and push your images, test them, store them, link them to the Docker cloud so that you can deploy to your host machines also. Multiple things like team collaboration, automation, many things you can do with the Docker Hub. And this is the URL for the Docker Hub. You can always log in and push and pull your images here. Also, if you can see, there was a base image, OpenJDK 17 Alpine. From where do you think this image, the base image is coming? That is also coming from the default registry, that is Docker Hub. If you search here OpenJDK, you can see this is the official Docker image for OpenJDK variants you can use with the images. That was all about Docker Hub. I have many more things to cover in Docker. Say the Docker's component, the architecture of Docker, what is Docker daemon, what is Docker registry, what is Docker compose, Docker networking, Docker storage, what is Docker architecture, difference between Docker and VM, virtualization, hypervisor, Docker lifecycle, cheat sheet, and the best practices. Many things I need to cover. Also, I need to cover the live demonstrations for the demo we have created for Dockerizing a Spring Boot application and Dockerizing a microservice application, and how to interact with the MySQL database created as a separate container. So here you can see I have different microservices interacting with a MySQL DB, and it is working fine. So how did we achieve microservices interacting with a database which is external container? Many things I have to cover. If you want me to cover this, let me know in the comment section. I'll create second and third part of it. And also please help me in deciding whether I should continue with the theory or first I should start with the demonstration part. If you say that if it is the live demo that you need, I'll switch to the live demo and then we'll continue with the theory. Else, first I'll complete the theory, then we'll move to live demo. I need a help on this particular decision from you guys. Thank you so much for staying back so late with me. We'll see you in the next video. I'll be waiting for your comments. Thank you.